Hello, my name is Mike, and I'm going to explain what PGP is. So what is PGP? PGP stands for Pretty Good Privacy. It's an email security tool, encryption tool that was made by Phil Zimmerman in 1991. It's completely open source, and we're going to talk a little bit about what PGP can do. PGP can offer confidentiality and authentication, and it can combine the two of them as well. So let's go and get into how it works. So first, we're going to start with an example of Bob writing an email to Alice. It says, "Dear Alice, let's get a pizza." So then the second step is that the PGP tool compresses the message, and just for the fun of it, I used an online compression tool to compress this message down to that. So there are some advantages to compressing the message before doing the actual encryption. The first advantage is that it saves resources. There's less room that you have to store in memory or on disk. Second advantage is that it strengthens the encryption. And the reason why it does is that a lot of hacking software that tries to figure out how to decrypt these things, the way that it works is it looks for patterns. And when you compress something, then the patterns disappear, or they're reduced, because the compression algorithms will look for patterns as part of the compression algorithm. And it makes it a lot harder for these this hacking software to be able to decrypt it because of that. So the third step is that the PGP will generate a random session key. This is just for one-time use, and we generated a random one down there for the purpose of demonstration. So fourth is we use the session key to encrypt the compressed plaintext. So this is our plaintext, which is the compressed plaintext that we had from step one. And this is the session key that we just generated. And using an online AES tool, I came up with this as our ciphertext. And so this is one of the two things we're going to be sending over or Bob is going to be sending over the network to Alice. So in the fifth, we're going to encrypt our session key. And what we're going to use to do is we're going to grab Alice's public key and use that to encrypt the session key. And with that encrypted key, we're going to send that over to the network as well. So that leads us to the sixth step, which is to send the ciphertext and the encrypted key to Alice. So decryption just basically works in reverse. Alice will use her private key to decrypt the encrypted session key to get the original session key, and then using that session key, she's going to decrypt the ciphertext to get the plain text. She'll decompress the plain text, and there she has her message. So what we just saw was how PGP can be used to create confidentiality. So next we want to talk about how they can be used to establish authentication. Now these are two different problems in security, where confidentiality is where we say we don't want anyone to read this message. And authentication says we don't necessarily care if people read it or don't read. We just want to be able to prove that it came from the right person, so that if Alice gets a message saying, "Hey, I'm Bob, do you want to get a pizza?" Then we want to be able to know that that actually did come from Bob and not from Trudy or anyone else. So first thing that we do to try to get authentication, the strategy that we're going to be taking is we're going to be building a a digital signature. So they're going to take the plain text and they're going to use a hashing algorithm. We use SHA-1. GPG I think uses something else. But they'll create a hash of that. Then Bob is going to use his private key to sign that hash, and then Bob will append that hash onto the message and send it to Alice. Along with this, if the organization has digital certificates, then PGB will create a certificate. And so some information that the PGB certificate will have is the version number of PGP, the certificate holder's public key, the certificate holder's information. So this might be like the name or the ID of the organization. They'll have a digital signature of the certificate holder. They'll have the validity period of the certificate. So if the certificate's only valid for the next half a year, that will be recorded there. And then the preferred symmetric encryption algorithm. So whether this is AES or RSA or any other algorithm, this will be recorded in the certificate. So just one last thing before we conclude this this presentation. We talked about authentication and we talked about confidentiality. The two of them can be combined if a message needs confidentiality and authentication. And the way that they'll do that is that they'll first sign the message and then they'll encrypt it. And then when it comes time to read it, they'll just decrypt it and then check the signatures to make sure that nothing has been changed. So yeah, that's PGP in a nutshell. Thanks for watching.